Over the last several decades, we've poured billions of dollars into biofuel research. So why can't you fill up with it at the gas station yet? Where are the biofuels? After all, the gas you put in your car is essentially an ancient biofuel. It used to be organic matter, mostly algae, actually, that over millions of years was compressed within the earth into fuel, hence the term fossil fuel. It consists of hydrocarbons, which we can burn, breaking those bonds to release energy that powers stuff, like our cars. So surely, in this age of modern science, we can engineer new fuels out of those same raw materials, right? Turns out, not so simple. See, the idea behind biofuels is that we use organic matter, like straw or corn or sugarcane, and turn it into liquid fuel. Ideally, the gases that are released when we burn that fuel are equivalent to the emissions that are absorbed by growing them in the first place. So the whole cycle is what we call carbon neutral. It produces zero net emissions. Plus, we won't run out of them because we can just grow more. That's why biofuels are so attractive. We could have energy security and reduce emissions, even create whole new agricultural sectors. But the amount of energy that's packed into that really potent fossil fuel is pretty hard to rival. Take ethanol, a common first-generation biofuel. It's an alcohol which requires plant biomass to be fermented, distilled, and dehydrated to take it from the crop we grow in the field to what you put in your tank. In the US, for example, we've mostly used corn, and just growing it in the first place requires intensive resources. Not just energy, but land, water, fertilizer that causes pollution, and growing corn for ethanol can directly compete with food production. After growing it, we have to then process that raw corn into fuel. This is time, money, and energy expensive. Plus, actually putting ethanol in cars is a bit of a stumbling block. In general, if we want to use different fuel, we'll have to change the way we make most cars, especially in the US. And ultimately, creating ethanol is so resource intensive, these fuel products can actually end up producing even more emissions throughout their life cycle than fossil fuels. Scientists have recognized these failures in recent years and have developed more efficient second-generation ethanols out of cellulosic material, the denser, inedible parts of crops. This doesn't compete with existing food pipelines and actually results in more energy payoff. But the distillation process remains expensive and energy intensive. It may be more energy-dense material, but it's also harder to break down into fuel in the first place. Brazil has had more success with sugarcane ethanol production, but all ethanols still have yet to break even in terms of practical, widely used energy parity. Okay, but ethanol's not the only biofuel out there. We also make biofuel out of algae, which, again, involves cultivating and harvesting these microorganisms, then putting them through an energy-intensive process that squeezes those lipids out of the algae cells. We then refine those oils and turn them into fuel. Same kind of problems here as with ethanol. We haven't been able to turn this process into something that, on the whole, creates less emissions and is less expensive than regular fuel because of all the resources that go into processing it. Plus, these organisms are plagued by predators in large cultivation ponds, and keeping them alive in industrial quantities is tough. But lots of cool research is going into fixing these particular problems. But what if we took an already processed food byproduct, like used French fry grease, and used it as fuel? We just need to refine it a bit through a process called transesterification into something called hydrotreated vegetable oil. This can and has been used to fuel large cargo ships and produces less carbon dioxide and polluting particulates than traditional fuel for these large energy-intensive vehicles. These materials are more energy-rich than first-gen biofuels like pure ethanol, but you guessed it, the conversion process is still really expensive. And biofuel like this works primarily in diesel engines, which aren't as common in some places around the world like in the US. In Sweden, however, HVO already makes up a vast majority of their biofuel, and biofuel in general makes up about a fifth of their transportation fuel sources, so it is a promising contender. We've been trying to make biofuel work since the early 1900s, and we're still not there yet. But we are innovating. Scientists are now genetically editing plants to make them produce more of the fatty oil we use to make the fuel, hopefully allowing us to get a higher energy yield from the resources we put into cultivating that organism. And some experts think that even as the market shifts towards electrifying cars and trucks on the road, biofuel is still a valid option for powering big, pollution-heavy vehicles like container ships and airplanes. Maybe the real problem is how we've been talking about all this. Everyone wants to hype biofuel as the thing that's gonna save the world, but we're still on the journey. Hopefully we won't give up yet because there's really exciting technology in the pipeline that could get us there, and that needs support. But the clock is ticking, and it feels like time and patience is running out. What do you think about biofuels? Still promising, or will something else beat green fuel to the road? Let us know in the comments below, and if you always want to check in on big questions like this one, don't forget to subscribe to Seeker. Thanks for watching.